So Heraclitus, he thought everything was made out of fire. Now there are some benefits from fire. If you start a fire, what can you do with the ashes? Somebody know? What can you do with the ashes? You can wash dishes. What else can you do?
You can wash dishes with ashes?
Filter water with them. Yeah, because it has kind of a corrosive. It's a caustic in the sense of being basic. If you put water and ash, you can make a kind of a base solution. It will kill some of the bacteria because there's metal in the ash, and the water reacts with it to form a hydroxide. But the most important thing you can do with ashes, you can, if you're getting bitten by bugs, you can rub the ash on your body as a mosquito repellent.
Oh, that's what happens when I think that's something about meat.
Yes. Also, you can brush your teeth with the ashes. Yes, because you're.
Isn't that true?
Well,
No.
bacteria tend to produce acids, right? And the ash would be kind of a base, so you're neutralizing to make salt water. So it can, in a prehistoric situation, if you've got a sore tooth or something, you're going to do whatever it takes, right? Okay, so divide 341 by 1,000.
Oh gosh, I'm gonna need to count.
Oh, here's one. Here's one. Does that work?
I think so. No, just one.
You want to do the next one? All right. Right there.
Okay. I should have known that.
I know. Sometimes if you do it more than once, it's quicker for you. Can't tell you the answer.
Should I put 0?
Yes, because that tells you there's a decimal there. Great question. All right, now if you look up here on the board, Claire asked a really good question. She said, should I put a 0 in front of the decimal? And you want to do that because some people might not see the decimal. So if you leave it off, they might think, well, it's 341 liters.
But if you put 0, they know what's up.
Right, they know there's a decimal there. All right, so who can do number 2?
Wait, wouldn't it just be, it's like, you just put a 0 at the beginning of all these, because thousands of,
So Adam's going to do number 2.
Julio.
Excellent. And then number 3, anybody do number 3? Anybody else? Now I'm giving 5 Bellward points for this. Normally I just give 1 because math is very important. And we want to stress the importance of math. Even though it's simple math, we want to make sure you understand how simple it is.
Wait, so did I just erase the answer and put the same answer, but with the different?
Okay, anybody? All right, Hannah? Boy, girl. Like to do boy, girl.
I go write half of it.
Do you want me to do like this again or just like the answer?
Yes. Can you do, because...
One, and then the... Leave half of it for me, Hannah.
Is that right?
No, you put 1,000.
Yeah.
Racer's right next to you. Okay. Now, if you look up here on your notes, you should be writing this. down, please, Cody. Write this down. I know this seems trivial and simple, but we want you to understand the significance of conversion. If you don't get this now, you're never going to get stoichiometry, which uses the balanced equation to predict reactions and predict the products you need to order the reactants. Now up here, we want you to note that this is incorrect here. You don't need to put that there, right? The conversion factor is 1 liter equals 1,000 milliliters, which you see right here. So you always try to find the unit you're trying to get rid of and the unit you want. They're going to say, I want this. So she got that correct. See how the milliliters cross out, and you get liters. That is correct. He didn't show the work here, but the conversion factor would be 1,000 grams to 1 kilogram, right? So if you didn't understand how you got that, this is what you're doing. Now stoichiometry is like 15 conversions. We're just doing 1 now. So if you get how to set these up consistently, chemistry will be really easy for you. So these cross out, you got kilograms. And then the last one, you don't need this as well. That one crosses out. Any questions on this? It's really pretty simple. If you didn't get it, go home tonight and practice this again, cover up the answers, see if you can do it on your own. Do it 3 or 4 times. Try to memorize one of them. If you can get one of them, when you take a test, you just write that one out that you memorized. It's like practice in sports. You know, you do the same play over and over again, so you're really good at it. So you go to that play when, you know, this situation is tough. All samples of a substance have the same intensive properties. Anybody know?
They're all from this one same thing. They're all from one of 4 things. Three things. Some of which we get. It has to be a type of one of them, but they all have one type of property that goes included.
Okay, now is a mixture a substance?
No.
No, a mixture is not a substance. That is correct. Good job, Garrett. A mixture, sorry, it's Monday morning. A mixture is composed of more than one substance. So that's kind of where this chapter is leading. It talks about homogeneous mixtures, heterogeneous mixtures, and elements, compounds. Those are the 3 main groups: mixtures, compounds, and elements. So is an element a substance? Yes, an element is a substance. And it's a substance because, like Democritus, you talked about you couldn't break down the atom. You can break down the atom, but that would be nuclear chemistry, and that's not typically done at the workplace. Usually that's done in like nuclear reactors, or when you get into like nanotechnology where you're trying to make new substances at the really small level. So we don't usually mess around with nuclear chemistry. Our goal really is just to do basic chemistry to make products and then sell them to consumers. Nuclear chemistry is fairly dangerous, so we don't like to, make the environment worse than it is currently. So up here we've got elements are substances because they have the same property. All elements, like carbon, all carbon has the same property. That's how you know it's carbon. So the first step was to break the elements down and group them. And then the second step was to determine the difference between elements and compounds. So compounds, how can you break them down? Compounds can be chemically broken down?
They're a mixture.
Yes, compounds can be chemically broken down. Whereas mixtures can be physically separated. And that's why mixtures are not a substance, is because of the physical separation going on. So like if you have water and salt, that would be a mixture. You can separate them, and we'll show you that in a couple days. That
Salt water.
Yeah, you can separate them into 2 different things. Now once you've separated them, you can no longer physically separate them anymore. And that's what makes up a substance. Is everybody fair? So if you can physically separate it, and it's not a substance. That's the important thing to remember up here. So they all have the same properties because they cannot be physically separated. You can't physically separate water can't, physically separate gold. All right, so moving on. Their property depends on.
Dependent on the amount of substance present.
Very good. Excellent. So an extensive property always depends on the amount of matter present. So extensive properties are associated with mass. Here, there are the things to consider when you might want to purchase a basketball, whether it's rubber or synthetic. And those would be intensive properties. Now, golf balls, you might want to be concerned about the mass of the golf ball. Because if you have a different mass golf ball, what can happen to you? You could get suspended or fined. You can't have balls that are not. They have to be a certain mass. Should you be cheating then?
So you said to consider what type of rubber or synthetic ball. Does that matter the size and different size?
Right. That's true. That could be in sports as well. Most sports when they play, they're going to use probably leather.
Yeah.
Consistently. Consistency is the most important thing. CO2 is increasing in the upper atmosphere. So I've got a little diagram here to show you that. And in the lower atmosphere, that would be the troposphere. That's where the temperature is increasing because of CO2. Troposphere. Now the stratosphere and the upper atmosphere, that's where CO2 is increasing and the temperature is cooling. Now I didn't learn this through the media, right? I didn't learn this by reading Time Magazine or the Courier Journal. I learned this because last year one of our students took this CO2 monitor and they did a science fair project. And what they did, they went throughout Louisville and they determined was the CO2 levels the same in the inner city compared to the suburbs. And they did a little graph and they showed that in the inner city the CO2 levels are higher than in the suburbs. So this Vernier CO2 monitor was purchased by a grant from Toshiba. So 2 years ago, the Mrs. Yaysayer, she's doing the little tennis court thing. She put in a grant to get us some money, and we won $15,000, and we used it to purchase these Vernier CO2 monitors. Now, what we're going to do here, we're going to demonstrate conservation of mass, and if you have a reaction, like a candle, right, you put the candle on the balance. So prior to putting the candle on the balance, you can see that the mass is 0. And then you put the candle on there, and it has a mass of 28.85. Okay, so we're currently at around 28 parts per million. Now go ahead and place that inside the container. Don't let it get burnt though. Just to place it to the side there a little bit like that.
Okay.
You see how it shoots up to 28, 34, 3,800 parts per million. So the CO2 monitor is showing us that CO2 is being produced. Excellent. So if we were to capture that CO2, then we could show complete conservation of mass. And you can do that. You can place a balloon on the top of it. It would put the candle out. And we'll show you that again tomorrow. There's another reaction to do. We can show you that. But I just wanted to show you today with this CO2 monitor. It's pretty neat that we can test the CO2 levels. And the CO2 levels would tell us, okay, gas is giving off. Then you would try to set up another test. Try to test what that gas is. Now, obviously, we know what it is, but this is kind of what Antonio Lavoisier did, and you'll read about that in the little cartoon tonight. to that. Hunters killing albino children for limbs.